Okay, so today we're going to be working on section 1.2, and we'll go through the notes together. These notes are on function notation and function evaluations. We'll do things algebraically. We'll eventually get to looking at a graph, learning how to evaluate functions with a graph, and then much later on we'll look at a table and learn how to evaluate functions tabularly using a table. But first is, I hope, the one you're most familiar with, and that is evaluating functions algebraically. So when you're given a formula, how do you evaluate a function? Before we get into examples 1 and 2, let's remember how to read this. This is the statement f of x equals, and then they give you the rule. So in this case, f of x equals 1 minus x squared. Okay? If I ever ask for f and then there's a number inside, we read that as f of the number, so in this case f of 2. And to find f of 2, it just means to find the value of the function, or y, when x is 2. Or for this example, f of negative 1 is asking you what is the value of this function when x is negative 1. And it's pretty easy to find these values. We'll do some practice examples. I'm going to do maybe 3 examples. I'm going to do f of 5. I'll do, maybe over here, I'll do g of negative 3. And then we'll finish with h of negative 2. Okay? So let's find the values of these 3 examples. If you feel like you're comfortable with function notation and you know what I'm asking, why don't you pause the video and knock out these 3 examples on your own, and then maybe come back and check your work. That's usually a good idea for most of the examples we're going to do, is maybe try it first on your own just to see if you even remember from Algebra 2, and that way you can kind of speed up this note-taking process. So f of 5, we are asked, what is the value of this function when x is 5? So normally, f of whatever the value is 3 times that value squared plus 2. So whenever you're asked f of a number, you're simply asked to plug in that number into the correct formula, in this case the f formula, plug in that number in for x and evaluate. So this would be 3 times 5 squared plus 2. Simply identifying the f function, plugging in the value 5 into the value x, and then now we're going to figure out what this equals. So PEMDAS, we're going to handle the exponent first. So that's 3 times 5 squared is 25 plus 2. Again, PEMDAS, we're going to multiply and then add. So 3 times 25 is 75 plus 2. Hopefully you get that f of 5 is 77. F of 5 is 77. What we have just shown is that when x is 5, y is 77. Cool. What about g of negative 3? Well, again, anytime you're given a function and if asked to evaluate it at a number, you're simply asked, plug in that number in for x and see what the answer is. Just make sure you're using the right function, in this case the g function, so I'm referring to this. 4 times something minus 9, in this case that something is negative 3. So 4 times x, but we're plugging in that negative 3 in for x, minus 9. So this should be a pretty easy evaluation problem. 4 times negative 3 is negative 12, minus 9. And negative 12 minus 9 is negative 21. So g of negative 3 is negative 21. When x is negative 3, y is negative 21. Awesome. Last one here is asked to find h of negative 2. The h function is quite a bit more complicated than the f or the g function, so we'll make sure we're careful here. H of negative 2, so we're definitely know by now that to find h of a number, you're going to plug that number into every x in the h equation. So that's going to be, okay, x cubed, so plugging in that negative 2 cubed, minus 2x squared, minus 2, plugging in that negative 2 in for x squared, plus 3. I have taken every x in the h formula and substituted or plugged in a -2. And now we have this, and now we just go with our arithmetic skills and see if we can't figure out what this equals. -2 cubed, remember, raising a number to a power is you're basically being asked to multiply that number by itself this many times. And -2 times -2 times -2 is -8. I'll let you verify that on your own. -2 times -2 times -2 is -8. We'll go slow here. -2 times, if we just tackle this first, -2 squared is +4. Plus 3. Okay. -8. -2 times 4 is -8, so -8 plus 3. -8 minus 8 is -16. And then the plus 3, so the final answer here should be -13. H of -2 is -13. When x is -2, y is -13. Okay, awesome. So that's evaluating functions so far. So I would like you now to try your best to do example 1 and example 2 on your own. Find f of -1, find f of -2. I'm not going to do those in this video, but there is a key to these notes. So practice on your own and then go check your answer with the key and make sure you got it right. And if you did get a different answer, try and see in the work where you messed up and then go ahead and fix that mistake for next time. Okay. Example 3. Find f of x plus 1. So this is quite a bit different than what we've seen. We're used to f of and then a number. We haven't seen before f of and then something that isn't a number. So how do we handle something like this? So I'm going to do example 3, x squared minus 3x plus 4. I'm going to do it on this piece of paper. Okay, so we're looking at example 3 here. Awesome. Well, let's just realize what function notation is really asking. For example, if I ask you what's f of, I don't know, 6. Well, we've just done this example several times. We know that we're going to take this equation, and everywhere that we see an x, we're going to replace it with whatever the number in the parentheses was. So we would say, okay, instead of x squared, f of 6 would be 6 squared. Instead of minus 3x, it would be minus 3 times, plugging in that 6, times 6, plus 4, and we'd get some answer. Okay? And this is true of any number, yes, but it's really true of anything. It doesn't matter what I ask you to plug in to the function. We can even get silly here, and I could ask you, what's f of smiley face? Well, if f of 6 is 6 squared minus 3 times 6 plus 4, then f of smiley face is really the same thing, but instead of plugging in a 6 in for every x, I'll plug in a, well, as silly as it is, I'll plug in a smiley face in for every x. Okay? Now, of course, this has no real mathematical meaning, but it is true that when we think of function notation, we have the letter f, so we know which rule we're referring to, this original rule. We're asked to evaluate it or plug in a 6, okay, and so we did, or plug in a smiley face, okay, and so we did. So then, how do you find f of x plus 1? Well, it's really the same thing. We're just treating this x plus 1 the same way we treated this 6, the same way we treated this smiley face. So if I want to find f of x plus 1, I know the rule is something squared minus 3 times something plus 4. Right? That's the rule. F of something is something squared minus 3 times something plus 4. So f of 6, we plugged in a 6 in for every x. F of smiley face, we plugged in a smiley face in for every x. So f of x plus 1, we're going to plug an x plus 1 in for every x, right? This is the rule of function notation. Whatever's in the parentheses, no matter how crazy or how unfamiliar, plug that thing into every x in the original equation. And then use your algebra skills to simplify. So, getting rid of the color now, so I'm just rewriting it in one color. X plus 1 squared minus 3 times x plus 1 plus 4. Let's just, distribute, reduce, combine like terms. Let's use our algebra to simplify this into a final answer. Okay. The first step is actually the most complicated. X plus 1 squared. If you go too fast, you may think that this is x squared plus 1. That's a very natural mistake, but remember what it means to square something. This is very, very important for all of our work this year. We're going to see this exact thing over and over again, so it's important that we start practicing this now. X plus 1 squared is really just asking you to take x plus 1 and multiply it by itself. That's what it means to square something. X plus 1 squared is x plus 1 times itself. Okay, so let's look at that in a little bit. So this is where this went. Okay, we can handle the minus 3 times x plus 1. This is, and I hope you remember the word, this is asking you to distribute. So minus 3x minus 3, and then please don't forget the plus 4. Okay, hopefully so far so good. How do you multiply things like this? Hopefully you remember the acronym FOIL, so we will need to FOIL this. I'll go slow this time and maybe the next time, but certainly towards the end of these videos, we'll just be foiling at pretty quick speeds. So hopefully you remember how to do this. First is x times x, or x squared. That's the f. O is outer, so the two outside terms, so what's x times 1? And x times 1 is positive 1x. The I is for inside, or inner, so these two on the inside of the term, so 1 times x is again positive 1x. And then the last are the last terms of each factor, so 1 times 1 is 1. Okay? I know I went slow there, but hopefully you remember that process. So that's how we foiled these two. And then let's not forget the minus 3x, minus 3 plus 4. Okay. And then the last thing is just to combine like terms. So there's a single x squared term, so that's nice. There is 1x plus 1x minus 3x. These are my only x to the first terms. So x plus x is 2x. Minus 3x is negative 1x. Hope you remember that. And then finally, positive 1 minus 3 plus 4. This is going to be positive 2. 1 minus 3 is negative 2, and negative 2 plus 4 is 2. Okay. So f of x plus 1 is x squared minus x plus 2. Okay. Pretty tough example. I think we'll all agree that it's way easier to find f of a number, but it's not the only thing we can do with this stuff. We can find f of an expression and get an entirely new function. Cool. So that was example 3. Example 4, we'll run through these 4, and then we'll end the video before I tackle example 5 and the rest of the worksheet. So example 4, I've got parts A through D on this page here. So we're going to look at example 4, where the function is negative 4x plus 10. And we're going to find A, B, C, and D. Again, I'm going to do this on a different sheet of paper. Okay, so this is example 4 from the notes. Let's knock out these 4 parts, and then we'll be done with the video. F of x is equal to negative 4x plus 10, so a pretty simple function. Maybe you think on your own what kind of graph this has, negative 4x plus 10. Should be a pretty familiar form. Maybe you even recognize this as y equals mx plus b form, so hopefully you see that this is a line, but that's not the point of this problem right now. Right now we're asked to evaluate this function at different points. In this first example, what's f of negative 2? Well, we've seen this several times already. That's negative 4 times plugging in that negative 2 in for x times negative 2 plus 10. So when I plug that negative 2, okay, I'm here. What's negative 4 times negative 2? That's positive 8 plus 10, which is 18. Okay, f of negative 2 is 18. So when x is negative 2, y is 18. We haven't talked about this yet, but what that kind of means for the graph is when x is negative 2, that's here, y is 18. So when x is negative 2, y is way up here at 18. So by going through this process, we now know that this point here, the point negative 2 comma 18, is on the graph of this function. And we could do that for a lot of other points and realize what this thing looks like if we wanted to. Okay, so that's an easy way to graph things. So you can see already kind of how evaluating these functions can help you graph things if you maybe forgot what they look like. Start plugging in numbers and getting out coordinates. Cool. Okay, what's f of x plus 1? Well, we've kind of just talked about what it means to evaluate a function at a number. We know how to do that. And we just learned in our previous example how to evaluate a function at a expression or something that isn't a number. And it's the same idea. We're going to take the rule negative 4 times whatever's in the parentheses plus 10. So if negative 2 is in the parentheses, then it's negative 4 times negative 2 plus 10. If x plus 1 is in the parentheses, then it's negative 4 times x plus 1 plus 10. We're taking whatever's in the parentheses here and we're substituting it in for x. Negative 4 times that plus 10. Okay? And then we distribute or multiply or do whatever we need to do to simplify this into a final answer. And distribute is the key word here. Negative 4x minus 4 plus 10. So as a final answer, we're going to get negative 4x, and then negative 4 plus 10 is positive 6. Great. Moving right along. What's f of x minus a? Okay, f of x minus a. So yet again, we're taking our original rule here, negative 4x plus 10, and instead of plugging in a negative 2 in for x, instead of plugging in an x plus 1 in for x, we're going to plug in whatever's in the parentheses, x minus a. So negative 4 times x minus a plus 10. That's an a, not a 9. Okay, plugging in x minus a into the function, and then we'll distribute, combine like terms, and be done. Negative 4x, we're going to be super careful here. What's negative 4 times negative a? Positive 4a. Careful with those signs, plus 10. And we're done. There's only one x term, there's nothing to combine there. There's only one a term, there's nothing to combine there, and there's only one whole number. So we're good. This is as simplified as it can go, right? If this was negative 4x plus 10x, then maybe we could do some simplifying, but it's not, so we're done. And then the final example is very similar to part C. What's f of x plus h? Well, again, we're going to take this rule here, negative 4 times whatever's in the parentheses plus 10. That's the rule. Negative 4 times whatever's in the parentheses plus 10. In this case, x plus h is in the parentheses. So negative 4 times whatever's in the parentheses plus 10. That's the rule. Negative 4 times, plugging this in, x plus h plus 10. Hope you're okay with that idea. If there's a negative 2 in the parentheses, then plug that number in for x. If there's an x plus 1, plug that in. An x minus a, plug that in. An x plus h, plug that in. That's function notation in a single sentence. If you want to find what this equals, plug in whatever's in the parentheses in for x in the original equation, and then evaluate or simplify. Minus 4x minus 4h plus 10. There are no like terms to combine, and we are done. Awesome. Okay, so that was 4 parts A through D there on that paper we just finished with, and in the next video we'll look at 5 and the rest of the notes.